Darshan, shall we start? Good morning, everyone. This light, yeah. So good morning everyone, and thank you Darshan for nice introduction. Uh, Today I am going to talk about assessment of semi-arid river basin flood using DEM and 1D hydrodynamic model. This particular presentation is an actual case study. Uh, we have tried to analyze semi-arid for river basin flood which has occurred in 2017. Let us begin with a good note. I'll show you the content of the today's presentation, the citation of this article. If anybody feels this particular presentation mentioning in their research project, research paper, dissertation, etc., they can cite this article with this citation. Let me start my presentation with a good note. You all know that cyclone Amphan batters Bengal, and in Odisha 6.5 lakh people get evacuated. You will be surprised to know that in Odisha the disaster management cell have done the arrangements in advance in such a way that the loss of life we can able to keep minimum. This is the first disaster maybe in the history of India where we find loss of life minimum. That is only 2 people died. That is again one due to falling of wall and one another guy who died. No, but they were not directly what we can say the victim of the storm, but maybe after victim storm the 2% died in Odisha. So this shows that the Indian disaster management at the same time the hydrology, hydraulics, knowledge of hydrology, knowledge of hydraulics, the IMD forecast, and overall the forecast for the cyclone, measures, flood managements, measures after the disaster, these all are improving like anything in India. So this is the positive note with which I am starting my today's presentation. There are other things also to share about the Indian hydrology, CWC, Central Water Commission, Hydrology Project 1, Hydrology Project 2, Hydrology Project 3, and lots of things has been done through these hydrology projects, and the flood management, hydrological events management, that has becoming more better and better in India. The second picture, you know that in India soon the monsoon will set. In India we have 3 seasons, that is summer, winter and monsoon. Usually India receives, majority of part of the India receives rainfall from June, July, August and September, and the monsoon from 5th June, it was predicted that by 5th June the monsoon will start from Kerala and it will forward in other parts of the country. But because of the cyclone Amphan, Assam witnessed first pat of floods. And you will see that this is a highway which has been washed away by flood water. And nearly 33,000 people of 11 districts of Assam, they were affected by this particular rainfall, which has occurred from 23rd May to 28th of the May. So you will see below the figure, I specifically mark italic and red incessant rainfall. This means that the rainfall which is continuous for number of days and in magnitude it is more than that of the average rainfall which resulted into the flood. And this is the state of Assam, 11 districts of Assam, 33,000 people, they get affected by this particular flood. We know that India has witnessed a rapid growth in population in last 50 years, which caused change in land use pattern, cropping pattern, water storage, irrigation and drainage. Due to this, hydrological cycle of semi-arid regions has been modified. The impact of climate change which includes increased precipitation and storm intensity, particularly in semi-arid region, resulted into increased chances of flooding in the cities located on the banks of the river and in the floodplain. Floods are most frequently occurred natural disaster in India. It affects the emotional, social, as well as economic life of the people who are affected by it. Floods are mainly caused by excess rainfall, which generates more surface runoff. But anthropogenic activities has increased the risk of flooding. Thus, reliable hydraulic models are required to accurately predict the water level and flow at various locations along the river. In July 2017, India witnessed a series of flooding due to excessive rainfall in the monsoon season. The states like Assam, Gujarat, Rajasthan, Odisha, Madhya Pradesh, Tripura, and West Bengal were flooded in many parts, which lead to the loss of life for hundreds of human and several animals. Also caused extensive damage to infrastructure. The regions which were not flood prone earlier are also facing floods frequently. For example, the semi-arid region of Gujarat, northern part of Gujarat, Aravalli, Banaskantha, Gandhinagar, Mehsana, Patan and Sabarkantha was affected by severe flooding in July 2017 due to heavy rainfall. The present study was carried out for the semi-arid region of Banas River Basin located in the northern part of the Indian state of Gujarat, which is flooded in 2015 and 2017 because of change in climatic conditions. Due to less number of available surveyed river cross section in the region, hydraulic studies have not been carried out in that zone. In the present study, river cross section have been extracted from SRTM DEM of 1 arc-second using Mike Hydro River software to overcome the problems of less available surveyed river cross section. So in the present analysis, first point to be noted is that SRTM DEM of 1 arc-second has been used and Mike Hydro River software has been used for the purpose of the analysis. Why this is required? Because there were less available surveyed cross section, and you know that without surveyed cross section we cannot carry out any flood modeling analysis. Those cross section were used for development of 1D hydrodynamic model for the Banas River Basin using Mike Hydro River. Those who are aware of Mike softwares, earlier this Mike Hydro River was called as Mike 11. With some additions and improvement, Mike 11 has been now renamed as Mike Hydro River and was calibrated for 2017 flood and validated for 2015 flood. In the present study, the 2 flood events have been considered, one flood event of 2017 and another flood event of 2015. The validated model was used to compute the water level to identify critical reach and the heights overflowing points along the 123 kilometer reach of river for peak discharge corresponding to 2017 flood event for flood control measures. Banas Basin River. Now, the basin for which we have carried out study, little introduction of it. The Banas rivers rises near Pindarwara village in Sirohi district of Rajasthan at an elevation of 372.5 meter above mean sea level. The total length of the river before it meets to run of Kutch is 266 km. The drainage area is 8,674 km square, and which out of which 38% lies is Rajasthan and 62% falls in the Gujarat state. The latitude and longitude of the rivers are also given. It is bounded by Luni Basin in the north, Saraswati Basin in the south, Aravalli Hill regions in the east, and finally the Arabian Sea in the west. The average rainfall in the Banas Basin is 921 mm. Please note this thing. What is the average rainfall of the basin? The average rainfall of the basin is 921 mm. Because of its topographical feature, the climatic conditions of the basin are variable. Mount Abu is one of the coldest regions and is a famous hill station in India, while at the other end, where the river confluences, is a little run of Kutch, which is desert with hot climate. From the digital elevation of the basin, it can be clearly identified that the region after the confluence of the rivers is almost flat with low elevation, which makes this area more vulnerable to flooding. Means where the river confluences in run of Kutch, that region is almost flat, and because of the flat slope, the vulnerability to the flooding that increases. So this is the study area and data source. You'll see that in India, on my extreme left side top, the map of India. In the map of India, we have shown Gujarat state, and where you see the red mark, that is the basin, and on the right side there is another figure which is the Banas basin. You will see that Banas river, there are two parts. One is coming from Sirohi, and the other one is on Sipu river, that is Sipu Dam is there on the other tributary of the Banas river. The confluence is near Disa, and then the river moves forward. You will find here Kamalpur is written, that is Kamalpur is the gazing site for this particular river, and further you will see that it beyond that of Randhanpur, it confluences into what you can say little run of a Kutch. So this is the what you can say map of the Banas basin, which is used for the present study for flood analysis. There are two major hydraulic structures in the Banas river basin, namely Dantewada Dam and Sipu Dam. Dantewada Dam is on Banas river at chainage of 105 km from its origin, with a catchment area of 2,862 km square. While Sipu Dam is on a Sipu river at a chainage of 60 km from its origin, with a catchment area of 122 km square. The releases from the dam are used for irrigation purpose. The study area of present study starts from the downstream of Dantewada Dam and Sipu Dam. Both the dam, the study area for which the flood analysis has been carried out, that is on the downstream side of the Dantewada Dam and Sipu Dam. Both Banas and Sipu river meets Bhadat village near Disa district, that is around 30 km from Dantewada and Sipu Dam. Means the Sipu river and Banas river meet each other 30 km downstream of both the dams. The end boundary of the study area is taken as Kamalpur gauging station, which I have shown you in the previous map, which is located in Banas river near Kamalpur village, 123 km from Dantewada. So the rivers Banas and Sipu confluences downstream of Banas Dam, that is Sipu Dam and Dantewada Dam at 13 kilometers. From 13 km, it flows almost 123 km. At 123 km, there is a gauging site named Kamalpur. So that Kamalpur gauging station, that is the village where the gauging site is there, where discharge is measured, and it is 123 kilometers away from that of the Dantewada Dam. So line diagram of this particular study area you can see on my right hand side, and try to remember it, because I'll be using this particular diagram number of times when explaining you how the flood analysis has been carried out. So you will see here Dantewada Dam, and then there is a Sipu Dam. You will find that after the Sipu river and Banas river both meet at 13 km downstream of that of the Dantewada Dam. From that you will see there is a pink color one what we can say station is that is Umri gauging station. That is an intermediate station between Dantewada and Kamalpur, Sipu and Kamalpur. That is the intermediate station after the Banas river and Sipu river that confuse at one particular point 13 km. From there it is 40 km away, that is a Umri gauging station, and from Umri gauging station to that of Narmada main canal, that Narmada main canal crosses this particular river perpendicularly, and that is 23 kilometers, and downstream of the Narmada main canal 47 km distance away there is a Kamalpur gauging station. Once again, I request all of you to look at this line diagram carefully, that there are two dams. Again, I repeat, there are two dams, Dantewada Dam and Sipu Dam. The river confluence is downstream of Dantewada Dam and Sipu Dam at 13 kilometers. From 13 kilometers onwards, at 40 kilometers from this, there is a Umri gauging station, which is an intermediate station. At 23 kilometers from Umri gauging station, Narmada main canal crosses this particular Banas river perpendicularly. That is at 23 kilometers. Then and after Narmada main canal, 47 kilometers away is a Kamalpur gauging station. The point to be noted here is this Narmada main canal, which crosses this river, Banas river, that is partly above ground and partly below ground. Why I am mentioning this? The reason you will come to know when I will be explaining you the results part, right? So remember, Narmada main canal is partly above and partly below the ground, and it crosses 23 kilometers away from Umri gauging stations perpendicularly to the Banas river. These are the photograph view of river from Dantewada Dam, right? There is the top photo, and the bottom photo you will see view of the river from Sipu Dam, right? Both the rivers, you see the bed is almost rocky. Why I am showing this? Because you can get idea that what Manning's value of N you have to consider for this specific river. At the same time, from the photograph, what you can see about the depth of the river? Can anybody write in chat? From these photographs, looking at this photograph, what will you comment about the depth of the river? Can anybody comment on chat? You can type in a chat. What is your observation? Any participant? What is your observation about the depth? Yes, Kamal, it is correct. You are saying 2 meters. That means you can able to see that the depth of the river is very less. Someone is writing 2 meters, 3 meters. Someone is saying yes, it is a with it is correct. That is shallow river depth. So one thing you observe from this specific photograph, that the depth of river is shallow. It is not the depth like the river Narmada or river Tapi when it enters into the Gujarat, and the depth of the river varies from that of a 10 meter to 25 meters. While here you will see the width. Again, the second observation from the photograph is you will see that almost the bank of the river and the depth of the river, right? Difference of elevation is very less. Right, so almost it is a flat, what you can say, the depth is very less, and because of that, what will happen when there is a excessive water release, probably this water will spread over the adjoining banks. That you can to clearly visualize from these two particular photographs, right? So that is this depth sufficient in rainy season. That's what I am going to come, Yogesh. That, but why I am showing this, so that you can understand when I will be explaining what happened into July 2017. You keep this particular photograph in mind, so that you can at that time, right, correlate what analysis I have done, what has happened in the river basin in July 2017, right? This is another photograph. You will see that either side of the river, and first you see the left hand side, the top photograph, it is almost the sand. You see there is no rock, because the rock site was near the dam. As you know, as the dam moves, as the river moves the downstream side, right, and as it confluences with the little run of Kutch, which is a desert, that's why you will see now the rocks are not seen on a river bed, but almost you will see the sand is seen. The depth of the river is very shallow. The width of the river is also, you can see. At the same time, the banks of the river on either side, right, what kind of vegetation and or vegetation is that, or that is land use, land cover is there on either side of the river. That gives you idea that what type of geography of this river is. You see the right hand side photograph, in which you see river also, and there is a gentleman. He is a Nikunj Mangukia, the co-author of this paper, who has actually visited the site and collected the data for this particular analysis. So this is another view of a bed of a river near Mota Jampur village. Earlier figure you were of the river depth around 2 meter to 3 meter, but in this particular figure, if photographs that is on the left hand side top, you will see that the depth of the river is less than 1 meter or 1.5 meter. So it becomes very shallow, and this particular photograph is taken near Narmada main canal. If you will see that the right hand side bottom photograph, view of the river near Abhiyan village downstream of Kamalpur gauging station. So Kamalpur gauging station is the last gauging station. After that you find what you can say, the river is almost flowing flat, having no slope, so almost plain, right? So you will find that someone M is typing that it's very important for me that river bathymetry be estimated using satellite telemetry and satellite optical image. Please wait, this only I am explaining the study area, and this study area I am explaining you to just have what you can say contact between flood analysis which I have carried out and what are the river situation. Yet I have not come to the technical part of this particular analysis. So please wait. Okay, so these are the photographs of what we can say study area, so you will get idea. Right now comes the data source. So M, your answer lies over here. The data required for the study were obtained from the relevant field agencies responsible for the measurement and validation of the data. The necessary data required for modeling and its source. So first of all, we have collected flow hydrograph of Datiwada Dam, and that we have considered in this particular modeling as an upstream boundary condition, right? And the data we have collected from Datiwada Dam Authority. Then flow hydrograph of Sipu Dam, that is also given as an upstream boundary condition, and the source is Sipu Dam Authority. Then stage and flow hydrograph at Kamalpur gauging station, that is given as a downstream boundary condition, and the data has been collected from Central Water Commission CWC Gandhinagar. Stage and flow hydrograph at Umri gauging station for calibration and validation purpose, that has been collected from River Gauging Section Office Palanpur. So these data were collected, what we can say, from the different offices. The methodology includes the identification of causes of floods, development of one-dimensional hydrodynamic model, flood damage assessment, and preventive measures. The causes of the flood have been identified firstly by means of rainfall data, topography of the region, newspaper articles, and government reports. The second step was to collect the required data for the present study, which were procured from the competent authorities and public survey. So you will find that the data collection itself is a Herculean task, right? So this is the methodology used for developing of 1D model. You will, starting from the left hand side top, identifying the causes 2017 Banas river flood, that is collection of required data. This required data has been used for development of 1D hydrodynamic model, that is river network, cross section, HD parameters, boundary conditions. Using the river cross section, the selection of initial Manning's value of N has been carried out. The simulation of 1D hydrodynamic model has been done using Mike Hydro River. After development of the model, we have computed RMSE, NSE, and R square, that is the statistical parameters to compare observed water level and the simulated water level. If the observed water level and simulated water level agrees or matches well, right, up to the required accuracy, then it's fine. Otherwise, we have changed the Manning's value of N, and that is again used for 1D hydrodynamic model, and the model has been rerun several times. Then the simulated water levels for Manning's and corresponding to lowest RMSE and higher R square, that has been selected, and that's using that a critical section has been identified from where the flood water has entered into the nearby areas. Is it possible to obtain a DEM with higher resolution than SRTM using open source data? Yes, definitely. And even the 1 meter resolution data are available. Leon, 1 meter resolution data data are available free of cost from European satellites. You can search from the net and you can get those data also. And it's true that in this particular analysis we have used SRTM data, SRTM DEM of 30-meter resolution. Okay, so these were the methodology. Again, the causes of 2017 Banas floods. Let us first understand before going into the analysis of flood using our Mike Hydro River software and the steps which I have shown in the previous slide. Let us first understand that what has happened, because sometimes when I am showing this title, assessment of semi-arid river basin flood, so one who is an expert of hydrology, one who knows the water resources engineering, he looks at me with surprising face. He looks at me that I am talking something absurd. Why? Because when I am saying semi-arid river, semi-arid basin, and at the same time I am talking of flood, it is something like I am talking of what we can say making a coffee on top of the Mount Everest. Right, of course it is possible nowadays, but I am saying that something make cooking hot, or you are saying that you are doing something which is very hot on the top of the Mount Everest. So first we are trying to understand, right, what happened, why there was a flood in 2017 in Banas River, why I said that I wanted to analyze, or I wanted to assess the flood of semi-arid river. So first we will see that what has exactly happened during 23/2017 and 24/7/2017. These are the 2 days, 23rd and 24th. If any one of you is attending from now to north, and if he or she belongs to this Banas River Basin area, for them that this particular event was not less than any disaster. It was completely a disaster, right? What has happened? So let's see. So Banas River, one of the 2 major west flowing river, having total basin area of 6,112 kilometers square, was flooded in July 2017. Due to these lines are very important, unprecedented inflow in the river. Underline this, unprecedented inflow in the river. Unprecedented, what do you mean by unprecedented inflow in the river? It will not be possible to understand, right, that unprecedented inflow in the river, and how, if it happens, what happens, what will happen to the downstream side people, how the dam be saved. These are the questions which one need to address, right, or one need to understand, right, by meaning of this unprecedented flow. The Mount Abu, Disa, Banaskantha, Dantewada regions of the catchment received rainfall of, just see the values now, 1,473 mm, 269 mm, 150 mm, and 490 mm respectively within 48 hours. Right? See how much? 1,473 mm. Okay, then 269 mm, 150 mm and 490 mm of rainfall in 48 hours. I asked you the average annual rainfall of Banas Basin, that is 920 mm. You understood what I mean to say? The rainfall which occur in 4 months, which is equivalent to 921 mm, has been fallen on only in 48 hours. That too 1,473 mm in Mount Abu, right? And why am I worried about the Mount Abu? Why I am worried about the Mount Abu? Because the river originated from the Mount Abu. When I am saying 1,473 mm, we have seen in the previous slide the Banas River originated from the hilly regions of Sirohi, which may be a part of what you can say the Mount Abu, that is Mount Hill region, and because of that there will be excessive inflow into the river, or excessive flow in the rivers, and that too happens in 48 hours, 27/2017, and that is 24/7/2017, right? So this is the reason because of which, and again you just see that this historical data shows that the rainfall occurred on 23rd and 24th July was the maximum of past 112 years. right? The rainfall occurred, right? That is what you can say 23rd and 24th July 2017, maximum of past 112 years. The rainfall was of the magnitude which is more than that of 112 last 112 years of the rainfall, right? So Orato, what international parameters do you use to determine the size of basin, sub-basin or micro basin? Where can I download the reference? I'll tell you the later on, right? Right now I'll be explaining this flood, the basin classification and all that. I have one more paper that is published in disaster risk reduction journal, and if you will share me your email, I may mail you that particular what you can say paper to you, where the details of basin, sub-basin, micro basin, etc. are given. Okay, so what you can say, this is the almost what we the day on which what was the rainfall that I have explained. Yes, Jatin, Janice, I'll be explaining the magnitude also, that is height of elevation at which the river meets and how it flows. Wait for a while. So Mount Abu is the hilly region which drains the water either in the left side, that is Banas river, or right side, that is Sipu river. Water issued in Banas and Sipu river accumulates in Dantewada and Sipu dam respectively. As the upper catchment of Banas river is covered with hills, the runoff generated from the rainfall is much higher with less time of concentration. This is also very important, less time of concentration. Thus, both the dams got filled up to full reservoir very rapidly. The dams were already filled up to rule level due to local rainfall. Hence, the dam authorities were forced to release the water. Now, what has happened? The things that when this rainfall occurred, that was the month of July, and there was that is 23/7 and 24/7, right? But because of the good rainfall in the basin, the dam was already full, right? Or they were already filled up to what you can say full reservoir level. Okay, and due to this high inflows, because of this particular rainfall, it resulted into high inflows into both dam, that is Dantewada dam and that of the Sipu dam. Okay, then this is the what you can say showing the importance of study. This is a if you'll see the right hand side top, yeah, somebody asked about the elevation. This is the elevation what we can say image, or where it shows that hilly region which has an elevation of 1303 meters. Then you see the line that fall on this hilly region has moved into what you can say Sipu dam and Dantewada dam. That's why it is written that the time of concentration, the time to flow the water from the farthest point of the basin to that of the dam was very less in this case. So these two dams started filling fast, and when the dam started filling fast, and as I said, because of local rainfall, the dam were having good amount of water. They were having good amount of water, and because of that, what has happened, that the dam authority have got no other option than to release the water. Now I need a specific attention of every one of you to this orange line, blue line and gray lines. There are three lines. All of you please pay attention to it, what has happened, how has happened, and because of that what happened in the what you can say downstream area of the this particular basin. You will see on x-axis there is a time, on y-axis there is a flow. Okay, on x-axis there is a time, and on y-axis there is a flow. Okay, now you will see that rule level. That rule level is a green line, which is almost a top, which is having 25, 26, 27,000 cusac, right? That is 2,70,000 cusac. So that is 2,70,000 cusac. You find there is a what you can say green line. That is the rule level. Rule level means what? The rule level up to which the dam can be filled. Okay. So rule level of August is 182.5. That is 182.5. You will see that inflow. So inflow is a blue line. So you will see that on 23rd 7 midnight, the blue line. Now you follow the blue line. I am saying blue line, blue line. You follow the blue line and you will see that there was 50,000 cubic of inflow in few hours. Then there was what you can say less inflow, and then suddenly from 50,000 to 1,25,000 inflow only in few hours. Again, for few hours the inflow has gone down, and if we will see that on 24/7, right, that is 00 hours, after 00 hours and that of the first hour, you will see the inflow is from almost 10 to 20,000 to 2,70,000, right? And this happened in what time period? Only in few hours, right? So if you see the blue line, the blue line, that is 2,70,000. I request those who are writing in a chat to pay attention to the figure which I am showing. It's very important. You will see that on 24/7 the inflow, that is blue line, you see that within few hours, right from 10,000 to that of 2,70,000 inflow in the dam within few hours. So this makes authorities sleepless. Why? Because already the dam was full, and in that within few hours only, you find that the inflow was in terms of 2,50,000 cubic water flowing into the dam. What the dam authority will do? And you will see after the lag of 1 hour or 2 hours, the orange line, they have also started releasing the water, which started from 0 to 2,25,000 cubics, right? Why? If they don't do that, the dam may be in danger, right? If they have not released this much of water, because there was no cushion in the dam were almost full. And you see here the full reservoir level is also shown. You just see second y-axis. On second y-axis, which is a water level, and on water level you see 182 is your full reservoir level, and due to inflow they have stored the water up to the full reservoir level. And then immediately after, as they have got the information that the huge volume of water is coming, as the inflow is there in the dam, same time they have, what you can say, started releasing the water from the dam from 0 cubic to that of the 2,25,000 cubic in few hours, right? So what will happen because of this? If the releases are of such a high extent in few hours, imagine what will happen to the people who are residing on the downstream side of the dam, right? These peaks which I am showing over here, this is a problem, this is a challenge all over the world. This is not the problem of Banas Basin, or this is not problem of India. This is a problem of what? Why? Because of climate change and intense rainfall. When I'm saying intense rainfall, that means high intensity of rainfall in small duration, which leads to high inflows into the dam. And these inflows are so high that sometimes, right, the dam authorities are forced to release water from the dam to safeguard the dam. So you will ask me, sir, what's wrong in it, right? That is required to be done. If suppose the water is not released from the dam, then what will happen? The safety of the dam will be at risk. But if you are making the dam safe, what is the problem then? The problem is that the people on the downstream side of the area, right, they will get affected worst by released water if the released water is more than that of the carrying capacity of the river. If the water is more than that of the carrying capacity of the river, what will happen? The water will spread on the adjoining areas, that is in its floodplain. At the same time, it will spread it will follow the natural contour, and it will spread over the square kilometers of area nearby both the banks of the river. So this is very important figure. Just this gives you idea that how much amount of water is released in few hours by the dam authority, which comes out to be 2 lakh and something 25,000 cusac, right, only in some 3 or 4 hours. And because of that, what has happened to the downstream side of the people, that we will see. Not only that, but 2 lakh and 25,000 cusac of water they have continuously released for some hours, some 6 to 8 hours, and because of that, what are the entire area on the downstream side of these particular two dams, they were submerged. Okay, so you will see here again, that is the inflow, outflow, dam level and rule level, right, of the Banas flood. This is a dam level on another side, the same thing which I have explained you. Okay, that gives the flow hydrograph, that is on 26, this is on 25 and 26. The previous one was on 23rd and 24, 23rd to that of 27 full, and out of that again in this figure it is shown it clearly, right, on 24 and 26 what has happened, right. So this is 2017, I think that is 2017. Okay, so this is the what you can say event, right, because of which has caused the havoc on the downstream side of these particular two dams, right, and this we have tried to analysis. So the water release from the Dantewada and Sipu dam merge into Banas river near Badhat village of Banaskantha district. The depth of the river after this confluence reduces continuously till the end, right. The reduced capacity of the river at the downstream side leads to lateral spreading of water and results in inundation of water in the region. Most of the river in Gujarat outfall into Arabian Sea. Also the river flow is very mild in Saurashtra and Kutch, and there was a 4-meter high tide in the sea during July 2017, right. That is why water was not draining. Right, this is the overall picture of this particular region. Also, the Narmada main canal, which crosses the river and constructed as partly above the ground, the canal obstruct the inundated water. Right. So what has happened that now still it is not over, sir. Just pay attention that there was a Narmada main canal, and as I said, in case of what you can say, the water which is released from both the dams, that will drain into the river. I have shown you the picture of the river also. The width is around 1 kilometer, but depth is only 1 meter, where you are releasing 250 cusac of water. Not only that, the 40 kilometers downstream of the Umri gauging station, there is a Narmada main canal. This Narmada main canal is partly above and partly below the ground. Okay, and there were siphon aqueducts, and through these siphons the river water flows. So this Narmada main canal has become an obstruction for the water which has released from that of the both the dams, right. So in the adjacent dam, the upstream side of the canal, in July 2017, this accumulated water in the upstream side of the canal resulted in several breaches in the embankment of the canal, which causes a flood in the downstream side of the canal. This Narmada main canal breached at 25 locations. Listen me carefully. This 2 lakh cusac of water which has been released from both the dams, right, that has made such an inflow that this contour canal, which was perpendicular to that of the river, right, has been breached at 25, minimum 25 locations due to this particular water, right. So that has also resulted into before flooding, it has resulted into increasing the depth in the region which is nearer to the canal, and after flooding it has resulted into the flooding of the areas which are on downstream side of the river, downstream side of the canals, right. So now we start with what we can say the hydraulic what we can say that modeling, 1D hydrodynamic modeling in Mike Hydro River. So 1D hydrodynamic model is developed in Mike Hydro River. The input parameters for the model such as river network, cross section, hydrodynamic parameter, boundary condition and simulation parameters are described step by step below. So creating Mike Hydro River model, setup of map configuration, setup river network, setup of hydrodynamic parameters. These are the steps which are required to be followed for developing of 1D hydrodynamic model in Mike Hydro River, right? So this is the picture of Mike Hydro River, wherein you can see that Mike Hydro product you have to select, then Mike Hydro model you have to find it out, right? And then you can input your data, right? Setup window, graphical user interface, data editing tool that is shown over here in this particular image, right? This particular slide, now I need your attention that how the model is developed. First, you see the extreme left hand side, that is simulation specification, modules, description, simulation period, time step control, computational and control parameters. So module, we have taken river, which kind of modeling we wanted to do, that hydrodynamic modeling. In that, again, the description, you see that Banas flood simulation, 1D hydrodynamic model of a Banas river. Then we have to give simulation period. For which simulation period? That is 23/2017 to 26/7/2017, right? Time step given, that is fixed time step. The time length is given 5 seconds, and the grid spacing is given 250 meter with dynamic high order friction. That is the computational control parameters that has been used for this. Somebody was asking for the DEM. So for DEM, you just see here map configuration, coordinate system, background map, background layer 3s, digital elevation model, and working area that has been given over here. The coordinate system used for DEM where WGS 1984 UTM zone 43 north, because this particular region lies in this particular zone. And then digital elevation model, use DEM for cross section creation, use DEMs for river by tracing, and what you catch a catchment delineation, right? You will see here the background boundary layers, that is 3 is given. Out of that, this background third, what details of background 3 are given, that you can see in this particular, what you can say, slide, which is shown over here, right? So this was all about the selection of parameters for running 1D hydrodynamic model in Mike Hydro River. So briefly, this is explained again, that river network, how to select the river network. Click on the file menu, select import, then select import from shape file. It provide options to import branches, alignment lines, structure, storage, boundary points, and distributed source and catchments. In present study, the model is developed for Banas River from downstream of Dantewada and Sipu Dam up to Kamalpur gauging step. The shape files of the river networks alignment lines are imported as branches and alignment lines. Then comes this is the picture you will see here. That is right hand side top, you see the Sipu Dam. Right hand side top, again the Dantewada Dam. Then you see Umbri gauging station in between the Kamalpur gauging station and that of Sipu Dam and Dantewada Dam. And downstream of it, you will find there is a Kamalpur gauging station. And in between, whatever you see, there is a different color, yellow and red. Sipu Dam cross sections are shown yellow. The Dantewada cross section dams are shown as Sipu Dam one was red. This Dantewada sides were yellow, and these are all the cross sections river network used in Mike Hydro River model. This which what we have, what you can say, made using that DEM. Okay, so cross section perpendicular to the flow direction has been generated in Mike Hydro model using DEM. The shape files of cross section as per the river width and important locations have been created using ArcGIS Desktop 10.5 and imported in Mike Hydro model to generate cross section at the location of shape files. Then the tool menu, use it, select auto generate cross section. A window will pop up with option select DEM and then select location from shape file. After importing location shape file, click on generate. So this way the cross sections were generated. So that map I have already shown. This is another picture of the Mike Hydro River, where we can see that how the cross section is generated using that is for a specific channel, right? And you can see also the depth of the river here. What is the depth of the river? If you'll see, this is 66 and this is 63. So approximately 3 meter is the depth of the cross section which is shown over in this specific what we can say the slide. Okay, then boundary conditions. Now these boundary conditions are very important whenever you do modeling of any particular what we can say case study. Then the boundary condition selection is dependent on the availability of data and the physical characteristic of the area. There are two things which particularly what you can say restricted to select the boundary condition and initial condition. Boundary conditions selection is depending on the availability of data and physical characteristics of the area. I know that this particular session may be attended by the postgraduate student, researchers, and faculty members also. I'll just request one thing: whenever you select any topic, right, either for the dissertation purpose or research purpose, or somebody approaches you, right, to give you the solution of a specific problem, right? For specifically, I'm talking from flooding point of view or flood analysis point of view. The first and foremost thing which you are required to do is check what kind of data are available for that particular river basin, okay, and what you can say whether you will able to get the data which you require to run in a specific model or for development of model. What I have observed that some of the researchers, without worrying about whether the data will be available for the analysis or not, right, they jump on the topic, right, and later on they find themselves or they put themselves in difficulty because the data which they required for the purpose of the analysis that may not be available. And if those data are not available, though the topic may be good, though the case study may be good, though the consultancy work which you are getting may be good, but if you are not having the data, you cannot do anything, right? So the boundary condition selection is depending on the availability of data and the physical characteristic of the area. The upstream boundary condition is taken as the hourly discharge from the Dantewada and Sipu dam. So we have seen in this figure that now when I'm showing the boundary condition, right, again I will go back to this particular figure and you will see there are two dams, Sipu dam and Dantewada dam. So I was having or we were having the data of inflows for Dantewada dam and Sipu dam for the entire period of analysis. For the entire period of analysis, we were having the inflow data for Sipu dam and Dantewada dam both, and that also I have shown you, right? This is my inflow data, right? If you will see this particular map which I have shown, right, this one. So this is my data, inflow data for both the dams, that is Dantewada dam and that of the Sipu dam, right? This is only for one dam. Similarly, we were having for the another dam, right? So this data has been used as a upstream boundary condition. That what I said, right? That boundary conditions you will find that the upstream boundary condition. Okay, then the stage hydrograph of Kamalpur gauging station is taken as a downstream boundary condition. When we wanted to do analysis, we should have upstream and downstream boundary condition. So when we want to give upstream and downstream boundary condition, what is there? So you have seen here that in this particular figure that so this is Sipu dam and Dantewada dam. This we have given as an upstream boundary condition. While the Kamalpur gauging station, the entire in between reach is my study reach, right? And therefore, the data of Kamalpur gauging station that we have given as a downstream boundary condition. And the data of Umri gauging station that we have used for the calibration and validation of the model. Right. So for the purpose of calibration and validation of model, that Umri gauging station stage and discharge data, they were available, that were used, while for the downstream boundary condition, the Kamalpur gauging station data, which is you just see that it is the end of the what you can say the river reach, right? And that data has been used for the what you can say downstream boundary condition. Okay, so upstream boundary condition we have given, the downstream boundary condition we have given. Once we have given upstream and downstream boundary condition, the initial condition provides option to the user to set the initial water level of flow in the model to make simulated results more accurate. In the present study, water depth of 0.4 meter is defined as natural flow in initial condition. So this 0.4 meter depth was given as an initial flow. Okay, then afterwards you will see here these are the data. these are the data. That is the Dantewada Dam. This is a Sipu Dam. So this is a inflow hydrograph for Dantewada Dam, inflow hydrograph for Sipu Dam, and this is the downstream gauging station state discharge curve. That is for Kamalpur gauging station. So left hand side, two top figures which you see, Dantewada and Sipu. That is my these are my upstream boundary condition. And if you will see right hand side downward graph, that is for Kamalpur gauging station, that is for what you can say the downstream boundary condition for analysis of this specific fault. Okay, so hydrodynamic parameter in Mike hydro model, the bed resistance value can be defined in two ways. One, global value, and second one, spatial varying local values. For the present study, bed resistance for the river is given as global value, that is the same roughness value for the entire river reach. The initial value of Manning sand have been given as 0.02, and for calibration of the results, it is assured that the value of roughness coefficient is within a specified range 0.02 to 0.03 according to type of channel. So we have followed the Vanti Chow's book 1959, and for that the values depending upon, because the personal visit, site visit was done, the river bed was seen, the photographs also I have shown, and based on that photographs, the value of Manning's that we have decided it will be within the range of 0.0 to 0.03 that we have considered, and then we have done the analysis. Finally, model has been simulated and the results has been compared with the observed results. The model has been calibrated by changing Manning's and value also. The assessment of the performance of the model has been carried out by calculation of different performance evaluation indices like root mean square error, Nash-Shuffle coefficient, and coefficient of determination. Right, that is R square. Finally, the critical river reach has been identified from the calibrated model for 2017 flood. So we'll see that next steps, that how it has been done. Right, so you see different performance evaluation indices. First, you will see root mean square error and its formula, then NSE, the net shuffle efficiency formula, and then the R square formula. These are the three statistical parameters that we have used for comparing the simulated result and observed result. For any of the model, for model development, always remember there are three steps. Number one, development of model. Number two, calibration of model. Number three, validation of model. Right. So when we want to do validation of model, we can compare the simulated results and that of the observed result. So how we can compare that simulated and observed results? So there are n number of statistical parameters that you can use and try to find it out how good are your model. For this specific analysis, we have used these three statistical parameters to compare what you can say the model results, that is simulated results, and that of the observed results. Right. So 1D hydrodynamic model has been set up in Mike Hydro for the flood event of the year 2017 and calibrated for a simulation period of 24 July 2017 to 26 July 2018, total period of 49 hours. Right. The maximum, this is wrong actually, this is 70. Okay. Maximum releases from Dantewada Dam was 6,465.9 meter cube per second, and from Sipu Dam it is 7,025.04 meter cube per second. These maximum releases were at the same time. See, this is the problem actually, right? They are saying the maximum release was 6,465 from Sipu and 7,000 from 7,000 from Sipu and 6,000 from Dantewada. Means at a time 6 plus 7, 13,000 meter cube per second water released from what you can say both the dam at the same time. And when 13,000 meter cube of water has been released, you will ask the people, because we have visited the site and we interviewed the people of the villages, and they said, sir, it was midnight of 23rd, right? 24th July, it was midnight of 24th July. And we found that we were sleeping on our local cots, right? And suddenly we find that there is a water below our bed, right? And the moment we realize from where the water is coming, right, and we are trying to run to a higher elevation, right, the water has reached to our chest height, right? Within few minutes, within few minutes on either bank of the river, the water increased or raised to a height of 1 meter, 1 to 1.2 meters, right? That the people were telling when we visited the sites who were residing very near to Banas River Reach. Right, so Banas River Reach, the people who are residing in near to this Banas River Reach, they were what you can say saying this type of things, right? And even I know that there is some Gujarati Lok Geet that has been made for this particular reason, and in that Gujarati Lok Geet also the same what you can say thing that has been sung, right, in a lyrical manner, that how the water has come, how people afraid of it, and before they understand anything, how the water has washed away, right, their belongings and animals and all that. That has been sung nicely in that particular song. You can view this particular song on this Gujarati Lok Geet on YouTube also. Right, so the results of Mike Hydro model can be analyzed using Mike View module of Mike software, right? And the 1D hydrodynamic model has been simulated for different values of Manning's roughness N. So here, the very important thing you can see for any modeling, that is table comparison of stage hydrograph for Umri gauging station for different Manning's N for 2017 flood. So we have seen, we have taken, as I said, that referred Venti Chow's book, and referring the Venti Chow's book, the Manning's N has been decided, the range has been decided 0.020 to 0.030. But for these various values of N, out of that, which value of N be good? So the model has been run for different Manning's value of N. The observed discharge has been find it out. This and observed discharge is already there. The simulated discharge from the model has been find out. That simulated discharge and the observed discharge is compared, and this statistical parameter RMSE, NSE and R square find out with different values of N, right, every time running the model, and out of that the best value of N has been selected, right, which gives you maximum value of R square and minimum what we can say RMSE. Right, so using that the calibration is done with the Manning's, that is 2000 flood data, the comparison of stage hydrograph for Umri gauging station for different Manning's value of N for 2015. For calibration of model, we have used the 2015 data, right, and flood data, and using that we again tried to calibrate whatever value of N we have got, right, and whether this can represent that river bed, right, used for final what you can say modeling purpose. So you will see that two different events are used, actually three different events are used. Here we have taken the tables for only two events, one for developing of model, one for calibration of model, and one for what you can say validation of model, right. And again you will see that here both the table, this is a Umri gauging station. Remember, this is not Kamalpur gauging station. Kamalpur gauging station is at the end. So model is calibrated using the data of Umri gauging station and validated using that of the Kamalpur gauging station. So both the sites are again different, right? And by that way, the model has been developed, and then the what we can say, the water from where it will spill, that we have tried to identify. So this is what you can say, the simulated water level and observed water level. The graph of comparison of observed and simulated stage at that, this is at Umri gauging station, that is the calibration of model, right, that is in 2017 flood, right. Then you find that 1D hydrodynamic model, this is for 2015 flood, from which we can find it out the value of final value of that of the N. Okay, so this is again a observed and simulated 45-degree graph with the same scale. You find this is 0.89 and this is around 0.83, that is observed value and simulated value, that is compared for again for water level using A and B, right, for the for the model. Okay, so from the simulated model, so Manning value as to 0.02, the results have been analyzed. Further, from the model, critical cross section have been identified, the maximum simulated water level, right, at all the cross section with RL of left and right bank, and changes has been shown in table. So using this model, Then we tried to find it out which are the cross section from which the water will spill over. Right, so you will see here the cross section change, right bank, left bank, water level, and what was the height of water level over the bank, that has been shown. So for example, if you will see 82,619 meter change, the height of water over bank was 4.362 meter on a right bank, and on a left bank it is 6.017 meter. Right, so right bank RL, this is the height above the bank, and left bank also it is around 6 meter at a change of 82,690. You will see further there are another changes, that is 44,491. The depth of water on a right bank 4.2 meter, left bank it is 5.07 meter, 19,760 it is 4 meter, this is 6 meter. This is approximately 1.5 story building. This is approximately 2-storied building. Imagine, right, that much of the water depth at this specific change. 12,169 it is 4.75, that is 1.5 story building, and this is 6 meter, that is 2-storied building height of water was there near this particular change, right, on the banks. Right, so this all we have read that most critical structures cross section identified from water surface elevation profile of the model are located at change 82,619, which is Disa Taluka, located downstream of the confluence of Banas and Sipu river. This Disa city or Disa town itself was the worst affected by this flood, and Disa is almost on the meeting point of these two, Sipu river and Banas river. Right, that what I have shown you when I have shown you the line diagram. Right, and that was the worst affected town of this particular village. Then at Chennai 44,491, which is near Umri village, and that is also affected because there was lot of water in that. And 19,760, just see here 19,760, how much my model says. Model says 4 meter on right bank, that is 5 meter approximately on right bank, and 6 meter on the left bank. This is near which village? It is Kharia. And those who read the newspaper and recall that this is the village from where around 10 people of one family drawn into this water. They were in one house and they all were drawn. 10 or 14 were there, 10 to 14, I don't remember exactly. Right, that is the Kharia village, and near this Kharia village 1900 and 760 meter. Right, you see what depth my model gives. Our model gives, that gives 5 meter on right bank and 6.3 meter on the left bank. So if imagine what would have happened, the people who are residing very close to the bank and have no first floor, they are staying on a ground only. And if they are staying on a ground and the water depth is 5 meter or 6 meter, what would happen to the people of that particular region? So this is the village where, as I said, that 14 people of the same family, 10 or 14 people of the same family that were died, right, in the Kharia village. The width of the river near confluence is around 3 km, while it becomes around 1 km near Disa bridge located at Chennai 82,619, which makes this area more vulnerable to flood. And the Disa Taluka was fully submerged due to 2017 flood in Banas river, has been reported by local media as well as government officers. Right, so the results also what are the observations, right, which we read from the newspaper, right, and local officials. At the same time, our site visits, they also confirm the results of the models which we have got from this particular analysis. So this shows the picture of what we can say Akhol Moti, Akhol, Ranpur Athon Vasa. This is the Disa. This Disa is the worst affected place of what we can say was affected during the 2017 flood. Right. So this is already the width of the river near Umri village located Chennai. This also decreases, and the surrounding regions are almost at the same elevation, which causes flood in this region. The highest overflowing cross section, which is located at Chennai 19,760 near Mota Jampur Kharia village, where the depth of river is around 2 to 3 meter. The Kharia and Mota Jampur village located at just upstream of the Narmada main canal. The canal is partly above and partly below the ground. So before the canal bridge, the water, what you can say, restrained by what you can say the Narmada main canal, and that is another reason why the water depth has increased, right, in these two villages, Kharia and Mota Jampur, right. And when we visited this particular region, we found that the people were staying in the floodplain area of the river because they were not aware, they have never come across such type of a high flood water in that particular region, and that is the another reason why number of people have lost life in that region because of 2017 flood, right. So this is the Umri village. You will see that very close, very nearer to that. This is on the right bank of this specific river, and it is very close to this, and the chainage is 44,491 and this is 45,126, right. So this is given is, yeah, this is a worst affected village, Kharia, and this blue line which you see, that is Narmada main canal, and that is partly above and partly ground. So before breaching of, because as I said that this Narmada main canal breached at 23 sections, right, of what we can say at 23 locations, but before breaching it has resulted into increasing to the depth of the villages which are very close to Narmada river and the Narmada main canal and the Banas river, right. And you will see here one side is the Banas river, another side the blue dark line which you will see not inside the river but this one, right, perpendicular to it, that is a Kharia village, right. So Mota Jampur is almost on the bank of the river. Just see here, Mota Jampur is on the bank of the river, and this Kharia, that is what we can say, that is on the near the river also, at the same time it is near the canal also. The canal is partly above, partly ground, so it has acted as a bund for the flood water which is released in the river, right. So before breaching, that has also resulted into increase of water level in the Kharia village, right. So that is shown over here. So you will see here what was the water depth at various section. This particular diagram shows you red is the 5 meter, right, the depth of white water which has flown over the bank. Wherever there is a red line you see, that is 5 meters. So you will find that after Umri, almost up to Kamalpur, the depth of water was around 5 meters. So 5 meter is approximately 1.5 story building water, right, that has spread over the entire region because of heavy releases and heavy rainfall in this specific region, right. So that is shown over here. Now these are the villages which we have identified which are exactly on the bank of the river. So you will see here Banas river, the red line is our what you can say Narmada main canal, and the yellow one, that is inundated villages. So these are all the list of the villages, right. You will see before the number of upstream of Narmada also and that of the downstream of Narmada canal also. You will find that the number of villages which we have identified, they were all under water of approximately 1 meter to that of the 5 meters, right. So that our analysis says, and these are the villages in future they have to exercise care when there is a heavy rainfall and high releases from the what you can say Ukai Dam, Datiwada and that of Sipu Dam. So that you find from this particular figure, right. So due to the floods, the livelihoods and lives have been affected in the region. The damages to roads, national and state level highways, railways and airports because of flood have impacted education and public transportation as well. 550 panchayat roads, 156 state highways and 5 national highways were affected due to Banas flood in 2017. For the rescue of villagers, National Disaster Response Force NDRF, Army and Air Force were also deployed with the State Disaster Response Force and Fire Brigade personnel. As per the officials of state administration, 54,570 people were shifted to safe areas due to flooding of low-lying areas. According to government official reports, about 4,333 villages having an agriculture area of 10.98 lakh hectare and 2,431 villages having horticulture area of 16,808 hectares were affected due to 2017 floods in North Gujarat. Devastating floods in parts of Gujarat damaged agriculture crops worth rupees 867 crore, while horticulture damages stands rupees 9.71 crores. As many as 6.44 lakh farmers have faced agriculture crop losses, and about 4,989 farmers have faced loss in horticulture crop. Almost 25% of kharif crops like groundnut, cotton, pulses, custard, cereals, and gore have been lost because of torrential rain and flooding in this semi-arid region. The electricity supply of 492 villages have been affected, right? And out of which 480 villages area were only in Banaskantha districts. As per the results of extensive survey of damage assessment by the state government, total payable relief for land damage, agriculture and horticulture loss stands as 1,653 crore. Cattle loss stood at 14,300, while 200 human lives were lost during the 2017 monsoon. This is a very painful and sad part of the, what you can say, this analysis, that or this flood, not of analysis, for flood, that 14,300 cattle have lost their lives and approximately 200 human lives were lost during 2017 monsoon. 12 members of the same family, that's what I was telling, 10 or 14, but it is a 12 members. So 12 members of the same family found dead in Kharia village in Banaskantha because of Banas flood in 2017. So this is the village which is nearer to Narmada main canal also. At the same time, it is on the right bank of the Banas river, close to the right bank of the Banas river, and because of that, what has happened, it has resulted into rise of the water level. And as I said, that the rise is around 4 to 6 meters, right? That's what my analysis says. And if it is so, those villagers who were not having first floor, or those who have not shifted, or those who have not moved to the safe area, you can imagine what would have happened to them. So this is one of the example, that 12 members of same family drawn into the water of Kharia village, right? So these are the picture, flood inundation due to Banas flood. You see here, for the square kilometers of area, you find that the river water has spreaded, right? So this picture, the top left hand side top picture shows, when I am explaining you that 2 lakh cubic of water has been released. What is the meaning of 2 lakh cubic of water when the river width is 1 kilometer, or let's say 3 kilometers, but having a depth of 3 meters only having a depth of only 3 meters, what would happen? So this is the example of it. You will see that for square kilometers of area, because water follows the contour, ground contour, and it spreads accordingly, you will see that for the square kilometers of area, you can see only water and water. Of course, this is because of, number one, releases from the dam, but at the same time, there was heavy rainfall in the area also. So there are two things which the photograph which you are seeing on the left hand side top is a result of two things. Number one, high releases from the dam, number one, and number two, because of heavy rainfall during the same period in the region, right? The right hand side bottom photograph that shows damage to the Taluka road in Banaskantha due to flood. That is the another picture which showing the damages because of this particular flood, right? Third figure, you can see flood water in Umri village due to 2017 flood, and flood water in Ebian village due to 2017 flood. That is on the, what you can say, right side bottom figure. And you will see that right hand side bottom picture, the left over which there is a shed, you will see approximately the depth of water is 3 meters, right? So those people who are residing here, if they have not moved to Surat place, what will happen to them? That what we can say, you can understand looking at this particular type of the figure, right? So this is again, yeah. Now the left hand side top figure, where I said that Narmada main canal has been damaged, right? So this shows the picture of, you will see that the far off there is a farms, right? If you see left hand side top picture, just see far off there is a farms, and this is Narmada main canal. So you can clearly visualize that Narmada main canal is partly above the ground and partly below the ground. So because of that, the water has breach this channel. You will see that this is actually the lined canal, and this lined canal has been breached at number of locations, and you will see that how the breaching has happened. That photograph is shown in left hand side top photograph, right? You will see there is a right hand side bottom photograph where the national disaster team, that is they are moving the people from what you can say to the safe place. So that particular picture is shown over what you can say, that is on the right hand side, the bottom figure. There is one more picture, right? So following findings can be summarized from the present study. Due to activation of, now why this happened, this is also one of the analysis which we have carried out, that why so much of rain has fallen. On the Mount Abu it was 101,473 mm, and in Mount Abu it has broken the record of more than 100 years. The rainfall on the Mount Abu during this period, that is 23rd June 2017 to 28 June 2017, the rain fallen on the Mount Abu, if you will check the record from the net, you will find, or the IMD, you will find that it has broken the record of 100 years of rainfall, right, which has fallen at the Mount Abu. So why this has happened? So the reason is due to activation of low pressure system in Bay of Bengal and Arabian Sea simultaneously. The Mount Abu, Disa, Banaskantha, Dantewada regions of the catchment received maximum of the past 112 years of rainfall, which is equal to 1,473 mm, 269 mm, 150 mm, 490 mm respectively within 48 hours. This is very critical. If you get the rainfall over a period of 7 days, probably you will not find what you can say the floods of this magnitude. But it happens. That's what I am saying. It's not a problem of India. It's not a problem of Asia. It's not a problem of European continent. But it's a global world problem, that the high intense short duration rainfall, that to manage that, right, it's a what we can say that results into the flooding, and analysis for that and the measures for that are required to be thought over, and measures be taken to prevent damages to the life, damages to the property, right, against the annual rainfall of 921 mm. The Dantewada Dam received an inflow of 260,000 7,000 cusac. At the time, dam was already filled up to root level 182.5 meter due to local rainfall 24/7/2017. This is another issue. We cannot keep the dam empty. Why? Because it's a semi-arid region, right? So in semi-arid region, people try to fill the dam even in the month of June itself, or in the month of July itself, if there is a rainfall, and they try to fill the dam up to what you can say full water level, because they are not sure whether they will receive. This is what I am talking of, Indian rainfall pattern, right? And no, semi-arid or arid region, whenever there is a rainfall, the tendency is that if dam get filled, they may be relieved from water shortages for next 1 year or next 2 years, right? And therefore that tendency made the dam to be filled full. And this is also, though this is a month of July, but dam was almost full to 182.5 meter, and the inflow was 267,216 cusac. So there was no option then the release water on the downstream side. Due to then next is the Sipu Dam received inflow of 373,000 cusac on 24/7, which caused the dam water level 186 meter, which is 4 meter above rule level. So even the dam authority tried to release less water. What they have done, they have stored 4 meter above rule level. They have stored the water in the dam, which is 4 meter above the rule level, so that they can release the water slowly. But there was no option. For the safety of dam, all the gates were kept open, releasing nearly 2 lakh cusac of water. The one-dimensional hydrodynamic model have been developed for Banas River reach from downstream of Dantewada and Sipu Dam up to Kamalpur Gazing Station. The maximum releases from Dantewada was 6,000, and from Sipu was 7,000. Approximately 13,000 meter cube per second water was released. The developed model has been calibrated for 2017 flood event and identify best performance for Manning's value of an 0.02. Right, so this is the Manning's value one can use for the what we can say carrying out analysis of the rivers of the same region. So that may be a help to them. The performance of the 1D hydrodynamic model has been assessed by different performance indices like RMSE, NSE, and R square. And the obtained value of RMSE, NSE, and R square for July 2017 flood are 1.618, 0.69, and 0.89 respectively. The critical cross section have been identified from 1D hydrodynamic model, which shows that the cross section of the river at Chennai is 82,000, which is Disa, near Disa Taluka, 44,000, that is Umri village, and 19,760 Narmada main canal are most critical cross sections. Right, following measures are proposed to mitigate the flood condition. The operation policies of both the dams should be revised to have a flood control reservation for the accommodation of flood water. When I am saying, right, operation policies for the dams should be revised, but again I say it is not that easy to revise the operation policy of semi-arid region. It is very easy to write in the slide that the operation policies of both the dams should be revised, but it is very difficult practically, because after this 2017 event we were carrying out, we have continued to do analysis of this Banas flood basin. After 2 years, when we approached the offices, when we approached the people and the what we can say, the concerned persons, they were of the opinion, sir, this has happened, it will not happen again. So that is the mindset of the people. Why? Because it is of a semi-arid region. They said that it is happened, but it will not happen again. Right? Why? Because they don't feel that this much, there will be so much of rainfall, there may be so much of water releases from the dam, and which will result into the flooding situation. But let me tell you that the changing climate and the increasing rainfall of shorter duration, right, may put this particular region or any region of the world at risk, because of what though it has not happened in last 100 years, or it has not happened in last 125 years. The planning policy should be formed to stop the habitat settlement and construction of roads in floodplains. Right, it happens when there is no road, what people believe, or no water, what people believe that let's settle very nearer to the river. Right, because then hardly you find any flood in the floodplain areas, and because of that, what happens, that people start living or settling near the floodplain areas. The capacity of available cross drainages in Narmada main canal should be increased to safely pass the flood water to the downstream of the river. Let me add here the information that yes, the Narmada main canal authority has increased the passage, that is aqueduct. They have provided more number of passages, right, wherein the water can be safely, the flood water can be safely taken from upstream to downstream without crowding the region. Right, so that step has been taken by the authority, and they have already what we can say, initiated the safety measure to pass the flood water. These are all references. Okay, this study is not possible without the funding from TEQIP3. So I thank Dr. Gandhi, Director of SVNIT, and Dr. J.M. McWan, who is the coordinator of TEQIP3. Apart from that, we have received help from the various officials, Ninama sir, Joshi sir, Kaul Singh, right, Bhavin Singh Rathod, Sri Anil Chaudhary, specifically Superintending Engineer Operation and Maintenance Anil Chaudhary sir have made because of his help, this particular study was possible to be taken up. Right, this Imam Ghachi, R.K. Thakur, Sri Vikas Barble. He is the Additional Executive Engineer CWC at Surat. But wherever we need his help for this analysis, because he is specifically dealing with the flood events and flood forecasting of Tapi Basin, right, CWC. So he has extended his help to us. We are also thankful to Sankwa sir, that is Chief Engineer, Ministry of Water Resources, India, P.V. Timbadia, that is Professor from Civil Engineering Department, Dhruvesh Patel, Associate Professor, PDPU Gandhinagar, Mr. Mark Britton, DHI Australia. This is he helped us for problems which we have come across in case of and doing analysis during Mike Hydro River. Then Pranav Dhawan is also from DHI. Then Pranay Nayak and Mr. Sajid Alam. These are from the DHI team who have readily helped us wherever we have come across any problem during what we can say the analysis carrying out this flood analysis. Right. So this is just for your information. Whenever you use this, please cite our reference. The citation I have given already in the beginning of this particular lecture. And in case of any queries, right, it may not be possible to answer everyone's query over here, but these are my email ID, sivnam27@gmail.com. You can please write me any small question, small query, if you are carrying out such type of a hydrological analysis or hydraulic analysis, and you need my help at any stage, right, or our help at any stage, definitely will be happy to help you. So quick question, one or two, Darshan, can we take one or two quick question? So if anyone have any, or if you have any identified any specific question from a chat, because I was presenting, and if you identify any specific question, you can ask me. No, discharge cannot be estimated, right? That is possible using drone. I think day before yesterday, that Dhruvesh Patel sir has presented his presentation, and it is available on a Facebook. So you can ask this question, person who has asked this question, Mr. Ram, right, to go through his presentation. Okay. Any other question? Okay. Okay. Any question from Facebook? Facebook, any questions? Any specific question is there? Check it. If any questions are there, we can take one or two questions quickly. See, it's a 1D hydrodynamic modeling. For 1D, it is not required. But if you are carrying out 2D modeling, then definitely it is required. For 2D modeling, the LULC map is required. It depends upon the data. Actually, 2017 is the flood, okay, and we have got more data for 2017 flood. We got data for 2015 flood. If you have how many numbers of event, better you go for the higher discharge event. So if you can go for the higher discharge event, because ultimately you wanted to compare the model and simulated discharges. So for model and simulated discharges, right, the one which gives you parameters which matches well for all the events, that particular thing is good. So you have seen here that I have taken 2015, 2017 and two gauging station, Umri and that is Kamalpur. Again, the range of N I have selected from 0.02 to 0.03. So it cannot be answered in a one word that you can select this. It's upon your data. You take the data, you go for the analysis, compare the simulated result and observed results, and find out which one is the best one. So ultimate aim of developing this model is, now this model is developed. So what you can do, that if suppose if you have a inflow data for a future scenarios, that this much is inflow in the Sipu dam and this much is inflow in Datiwada dam, then what will happen with the different water level in the dam itself, storage level in the dams, how much you will release and what will happen to the downstream side. So that you can able to predict, right? So that is the aim of developing this specific model. So that should come as accurate as possible. Okay. Before Darshan, 1 minute before you take feedback, I request all the participants and those who are attending on our Facebook, if you have any query or any sort of problem which we can discuss, or for which you need any sort of assistance, my email address is sivnam27@gmail.com. You can mail me at any time. Okay, so now you can go ahead, Darshan.
Darshan sir, I'm audible?
Yes, you are audible.
Great. So thank you so much. Met during one workshop at SS Gandhi College, Surat, and it was wonderful meeting you. And it is always pleasure to meet you again and again and learn many things from you. So this is superb. This was great seminar, and we have also learned many techniques which we are not already using in GIS. So maybe definitely will contact you. Will be in touch with you, sir, for learning. And this was superb case study. Like Banas was already needed this study. So this was very good from student and researchers' point of view, and maybe they'll learn many things from you as well, and will apply in their study areas and region using the different satellite imageries and different techniques that you already shown with the statistics and analysis. So thank you so much again, sir. Thank you so much.
Thank you.
Hello, sir. Uh, Obviously, sir, today's webinar was really too much informative and quite relevant to the field of water resource engineering. And it has always been a great pleasure and a better experience to get something to learn everything something new every day from Yadav sir. So thank you very much, sir, for this